Okay, let's talk about factoring. What is factoring? And let's go way back just to basic factoring. When you factor a number, like 12, you're figuring out what multiplies together to give you 12 back. And you want to get it in its simplest forms. So 12 is made up of 2 times 2 times 3. If I multiply that back, I get my number back. That is what factoring is. Now, the simplest form of factoring is when you have something that has been distributed and you're undistributing it. You're factoring it out. For example, 3x cubed plus 6x squared. Both terms have something in common that we can factor out or undistribute. They both are divisible by 3x squared. So if we think about that, 3x squared times what would give me 3x cubed? Well, that has to be an x. Plus, what would this need to be? A 2. If I distribute, I get my original back. You should always be able to multiply back and get your original. Now, going with that fact that it's undoing a multiplication problem, or creating a multiplication problem, let's remember how we multiply binomials. So I'm going to take 2x plus 3 times x minus 2. And let's look at what we get when we multiply those together. So I'm going to go ahead and use a multiplication box. It keeps you organized. It's also really helpful when it comes to factoring. So let's see how this works. 2x plus 3 and x minus 2. So what happens when we multiply those together? Well, 2x times x gives me 2x squared. 2x times negative 2 is going to give me negative 4x. 3 times x is going to give me a 3x. 3 times negative 2 is going to give me a negative 6. Now, when we take it out, we combine like terms. We end up with 2x squared, negative x, and a negative 6. The negative x really came from these two terms, these diagonals. Now, what I want you to notice here is that these two will always add up to the middle term to be the middle term. And let's see what happens, though, if we multiply them. This is something really fascinating. When we multiply these two together, so let's look at this. If we multiply those two together, we get 3x times negative 4x, which is negative 12x squared. Let's back up at the original problem. We can also get negative 12x squared by taking the first term times the last term. So, knowing that, we could take any, and I mean any, trinomial, split that middle term up into two terms, and be able to use the box to unmultiply it. Let's look at this one. And I'll do a simple one that we could have done in our heads maybe, but we'll just do an easy one here. X squared minus 14x plus 48. Okay, what we're going to do is figure out what those two diagonal terms are. Now those two diagonal terms are going to multiply to be those two together, which is 48x squared, and they need to add to be that middle term. So what two things would multiply to be 48x squared and add to be negative 14x? Now I'm not going to write that down every single time, but I want us to get an idea of what we're doing. So if I go to the box, I know the first term goes there. The last term always ended up being here, right? That's the first term, there's the last term. These two diagonals are things that multiply to be 48x squared and add to be negative 14x. Well, that's negative 8x and negative 6x. Now, if we're trying to unmultiply, let's think kind of back when we undistributed. What do these two have in common? They've got an x. X times what would have given me x squared? X times what gives me negative 8x? Now let's check here. X times what is negative 6x? Does negative 6 times negative 8 give me a positive 48? Well, if it does, then I have my factors. This would have been x minus 6 times x minus 8. Works beautifully. And the nice thing about it is it works if we don't have a coefficient there, or if we do, works the same way. And it even works on our special factors and things like that. So let's say I had 3x squared minus 10x plus 8. These two multiply together to give me that 24x squared. What multiplies to be 24x squared but adds to be negative 10x? Now the first term goes here, last term goes here. Multiplies to be 24x squared but adds to be negative 10. Oh, that's negative 6x and negative 4x. Now, what does the first row, what is this GCF? What do they have in common? What can we undistribute? They're both divisible by 3 and x, so we can factor out a 3x. 3x times what gives me 3x squared? X. 3x times what is negative 6x? Negative 2. X times what is negative 4x? The negative 4. Does negative 4 times negative 2 give me 8? Sure does. So we have 3x minus 4 and x minus 2. Beautiful. Last one. What if it's all combined? What if we have a GCF and we're going to have to factor it? 12x cubed plus 14x squared minus 6x. This has a GCF. Do you notice they all have at least an x? Now all divisible by 2. So we could factor out a 2x. And then we've got 6x squared plus 7x minus 3. Now, let's see. When I multiply those together, and I'll just do it right here, that's negative 18 plus negative 18x squared. So let's go ahead and write down, and we're just looking at what's in the parentheses right now. What's going to multiply to be negative 18x squared but add to be 7x? Well, that's a 9x and a negative 2x. And it doesn't matter where you put them, by the way. What does 6x squared and 9x have in common? Well, gosh, they have a 3x. 3x times what is 6x squared? 2x. 3x times what is 9x? 3. 2x times what is negative 2x? Negative 1. So this comes down, 2x. And this is 3x minus 1 and 2x plus 3. Easy breezy.